All right, today we're diving into a theory that isn't just trying to tweak our understanding of physics. It wants to tear out the whole rulebook and start from scratch. It's called quantum field dynamics, and it claims to solve some of the biggest headaches in science with one incredibly bold idea. The whole thing kicks off with a pretty wild question. What if the biggest puzzles we have, things like dark matter, the Big Bang, what if they aren't puzzles at all? What if they're just symptoms? Symptoms that we've been using the wrong rule book for reality this entire time. So, to really get why anyone would want to throw out the old rule book, you first have to see just how many cracks are in it. And these aren't small cracks. These are what we call physics' biggest puzzles. Look, when your best theories tell you that the universe began as an infinitely dense point, that's your math screaming at you that something is wrong. When you have one set of rules for big stuff like gravity and a totally separate, incompatible set of rules for small stuff like particles, it's a pretty big hint that you don't have the whole story. And, of course, when you have to invent mysterious, dark things to account for 95% of the entire universe, well, maybe the model itself is the problem. And it's into this messy situation that quantum field dynamics, or QFD, steps in. It makes a proposal that is honestly breathtakingly simple. What if the universe isn't made of all these different particles and forces? What if it's all just one thing? A universe from one single field. At the very core of QFD is the single idea, the psi field. The theory says, that's it. That's the one and only fundamental thing in all of existence. By itself, it has no properties. Instead, every particle, every force, everything we see and measure is just a different pattern emerging from it, like a ripple, a vortex, or a knot in this one underlying fabric of reality. And when you put QFD side by side with standard physics, you really see this isn't some small adjustment, it's a complete rewrite. Standard physics says the universe exploded into being about 13.8 billion years ago. QFD says, nope, it's infinitely old. We think of particles as fundamental points. QFD says they're just stable waves. We see time as a fundamental dimension. QFD says it's just an effect of the field. And dark matter, not a thing. Just a ghost in our old, broken model. Now, this leads to one of the most mind-bending parts of QFD. If everything really does come from just one field, then all the things we thought were fundamental, they're not. Reality itself is an emergent property. To help wrap your head around this, the theory gives us a fantastic analogy for time. Think about an hourglass. The sand falls, and that marks the passage of what we call time. But the sand isn't time itself, right? It's just marking change. Now, what if you filled that hourglass with water instead of air, or even honey? The flow of time would slow way down. QFD suggests the universe is just like that, where the local properties of the psi field act like that honey, setting the speed limit for everything that happens. So what about a particle, like an electron? In QFD, there are no tiny, hard little dots. There are wavelets. The best way to picture it is like a smoke ring or a little whirlpool in water. It's not a solid thing so much as it's a stable, self-sustaining pattern of energy within the psi field. And just like that, boom, the singularity problem goes away. You can't crush a pattern down to an infinite point. So the process of how something is created becomes beautifully simple. You start with the psi field in its calm, quiet vacuum state. Then, a concentration of energy creates a disturbance, a ripple. Now, if that ripple has the exact right properties, it can become stable and self-sustaining. And that stable, persistent pattern is what we measure as a particle. Okay, so if you've completely redefined what particles are and how time works, your story of creation has to change too. And this is where QFD makes its most audacious claim yet. It just gets rid of the Big Bang entirely. I mean, just look at the two stories side by side. On one hand, you have the standard picture, a universe born in a single violent event, a singularity that's been expanding and cooling for billions of years. But on the other hand, you have the QFD vision, a timeless, infinite universe that's not cooling down from some ancient explosion, but is just existing in a constant, self-regulating balance. But wait a minute, I know what you're thinking. What about redshift? Isn't that the slam dunk evidence for an expanding universe? Well, QFLD has a different take. It proposes that redshift is actually a tired light phenomenon. The idea is that as photons travel for billions of years through the psi field, they experience a kind of drag, losing a tiny, tiny amount of energy. Over those immense cosmic distances, that gradual energy loss looks to us exactly like a redshift. So, if the universe isn't expanding, what happens to dark energy, the stuff we invented to explain why that expansion is speeding up? And for that matter, what about dark matter? This is where QFD claims its next huge payoff, solving all the dark mysteries without inventing any new stuff at all.
Which brings us to the big question, right? If we toss out the standard story, what are dark matter and dark energy in this new model? What's going on?
According to QFD, they're phantoms. They're not real. They are ghosts in the machine, mathematical artifacts we were forced to invent because we were trying to fit the data to an incomplete, flawed model. They solve problems that, in the QFD universe, never even existed. So how does QFD explain what we see? Well, the dark matter effect, the extra gravity holding galaxies together, is explained by simple variations in the psi field itself. Think of it like a lens. A denser patch of the field can bend space-time more, making it look like there's extra matter there when there isn't. And dark energy? That's explained as an illusion. The intense light from distant supernovae loses a little extra energy near its source, making it look dimmer and therefore farther away than it really is. Okay, this is a beautiful, elegant story that ties everything up in a neat little bow. But here's the billion-dollar question. Is it science? The proponents of QFD argue that yes, it absolutely is. That this isn't philosophy. It's a testable source code for the universe. The entire theory is actually built from a single master equation, what physicists call a Lagrangian. You can think of it as the literal source code for reality. And the goal isn't just to admire it. The goal is to run the code, to calibrate its settings with real-world data, and then see if it can actually compute and predict the universe that we live in. And here's where it gets really wild. This computational approach claims to have a staggering advantage. For an extremely difficult calculation, like figuring out the properties of a proton from scratch, QFD's models are said to be up to 1 billion times more efficient than our current best methods. That's not just an improvement, that's a completely different leap. And this all leads to a clear, scientific roadmap to either prove or disprove the theory. Step 1 is to calibrate. You take known, precise data, like the Hubble constant, and use it to fix the model's fundamental settings. Then you lock them in. Step 2, you calculate. You use that fixed model to derive other things we know for a fact, like the mass of the electron, and see if it gets the right answer. And finally, if all that works, step 3 is to predict. You use the model to make brand new, testable predictions that experimental physicists can go out and try to verify. Which leaves us with this one final provocative question. Is the universe we see around us just the fading echo of a violent, singular Big Bang, still expanding from that one ancient flash? Or is it something else entirely? The steady, quiet hum of a timeless, ageless, self-regulating machine? QFD is betting everything on that second answer, offering a vision of the cosmos that, if true, would change everything.